Okay, cool. So yeah, just giving you guys the warning that this is just being recorded, just so you guys are aware. Um, cool. So today in lab, we'll go ahead and go over lab two. And then we're going to go ahead and go over like pointers and references, which I believe you guys talked about yesterday in lecture. Um, the pointers and references tend to be abstractly the most confusing things, I think, to students um, when it comes to this course. Uh, with that said, I think you guys are totally capable of understanding it. I think it's just one of those things that is a little bit confusing. Um, and it also runs a little bit longer today. I'll try to keep it brief. I know it's like already 5 o'clock. It's a pretty late lab. Um, but this one tends to be the longest out of all the like little lectures I give, just because there's a lot of nitty gritty stuff to it, and there tends to be a couple questions that go along with it. Um, cool. So with that said, I'll just go ahead and start sharing my screen and show you guys the spec for Lab 2. Some of you guys may have already started this, but hopefully this will clear up any questions that you guys might have if you do. Let me go ahead and open the chat up too in case anybody asks any questions. This out of the way. Sometimes this bar moves and sometimes it doesn't. I don't think you guys can see it anyways. All right, cool. Can you guys see this okay on my screen? I think I'm actually sharing the wrong. There we go. Okay, I'm going to assume you guys can see this okay. All right. So lab two, a little bit different than lab one. Lab one was mainly had to do with input output kind of stuff, right? This one, we're actually diving into classes, and you guys will be required to make some classes. So the three classes you guys are going to make in this lab are going to be the vehicle class, the showroom class, and the dealership class. These will all be their own separate source and header files for the vehicle, showroom, and dealership. Like all of those will have two files associated with them. And if we go over to the actual Zybooks, how this looks, the spec sheet isn't on Zybooks like it was in the past. You actually have to go to Canvas for the assignments under Lab 2 to find the spec sheet. So definitely go find this. Don't run at this blindly because that's going to take you forever to figure out what the code wants. You definitely want to go snag the spec sheet. So let's see what part we're on here. Let's go part one. So when you go to part one, it's going to be just the vehicle. Nothing's going to be filled out for you because that's your job. And that's going to be the only class you're really going to be working on for part one. All the parts are still due. I believe it's this coming Sunday or whenever your typical due date is. So make sure you do all the parts. It's just that he breaks it into parts, so it's a little bit more like compartmentalized on what you guys are doing. So I think it's a little helpful to do it that way. So the first thing is you're going to start with the vehicle class, and that is going to have a couple private data members, such as the make, the model, the year, the price, and the number of miles that it's been driven. So those are all going to be in your private section. And then your public functions will be all of these. He gives the return type and the name of the function, how it should be named, and gives some examples of like kind of what the output is. So one thing to note about this display function that I've seen trip a couple students up is actually, I take that back. The one that trips a couple students up is the get year, make, and model. So you're returning a string here, and the key thing here is that the year is stored as an unsigned integer. And you can't just concatenate an unsigned int onto a string. If you can, but what happens is it gets converted to like an ASCII character, and you're going to basically get this weird character depending on what number it is in front of the make and the model. So what you're going to want to do is actually just convert the year, which is an unsigned integer, to a string, and that can be easily done with this. And I'll go ahead and send you the link. Hold on. This screen share is in the way. Give me 1 second. Okay, there we go. So if you just Google toString for C++, you'll go ahead and get this like link, this top reference link. which I can go ahead and send to you guys here. But this is basically, you can read this to get familiar with what toString does, but it's basically used just like this, and you're going to pass your year into right here, and it will convert that to a string. So that's pretty straightforward on what to do there. And then you have your default constructors, and that's pretty standard. These are all this is the information you need to put in the default constructor for your vehicle. So moving right along to the showroom class. So this is a whole new class that's going to be part of part 2. And you can see when we click here that you have the vehicle and the showroom now. So you're going to have to fill out the showroom class as well. The vehicle class will be the same vehicle that you had before. You don't have to retype this, just copy and paste it over into this new part. Nothing about the vehicle should change if I recall correctly. So with the showroom, you're going to have the name of the showroom, which is, these are the private variables. The name of the showroom, a vector of vehicles. So this trips up a couple students as well. When the showroom is basically a class that stores a bunch of vehicles, because fundamentally that kind of makes sense. A showroom is a room that basically has a bunch of vehicles that you're trying to show off, right? So a lot of students get a little tripped up, and they think they're actually making the vehicle class like inside of the showroom, and that's a totally different thing. What's happening here is that the showroom has a vector that stores vehicles. So the showroom will have a data type, a vector data type that is going to store the data type of vehicles. So a vector of vehicles would be the same thing as like an array list in Java of vehicles, right? And that's a cool thing about these vectors is we can store any data type, and it treats objects just as their own data type. So that's some cool functionality we get. And then you're going to have a maximum capacity variable that you can't add vehicles beyond the limit that the showroom designates. Similar to the vehicle, you're going to get a default constructor that you're going to have to make, and then an accessor for the vehicle vector itself, which is the get vehicle list. And then you got a couple behaviors: adding a vehicle, showing the inventory, and getting the inventory value. And then he kind of breaks down these functions on what they should do. The dealership is super similar to the showroom. Basically, the way the vehicles are stored in a showroom, a dealership stores showrooms, right? So you're just going to have a vector of showrooms inside the dealership. So there's a lot of things that are similar between the dealership and showroom that should make it a little bit easier once you get to the dealership. And by the time you get to the dealership, which is part 3, a lot of this should be making sense at this point, and doing the dealership will be a little bit of a smooth transition. So same thing, constructors, behaviors, he defines the functions. These are some relevant readings for you guys that might be helpful. And then he gives a couple tips. One of the big tips is just start small. Just work with the vehicles, try to get that working, then do the showroom, and then do the dealership. He even says like it's kind of impossible to do the showroom or the dealership if you don't have the other 2 classes working, because you need those classes, right? Cool. And then this is just some example output. So I know I kind of flew through that. I got a lot to talk about with the pointers though. So are there any questions on this for the lab? All right, cool beans. So we can go ahead and get right to the pointers. Let's see here. Comment this out for now. This is all from the lab I had earlier today. Let's see here. Okay, so he talked about let's see, do this and this and that. Okay, that's all we care about for now. Okay, so I believe he introduced you guys to pointers and references yesterday in lecture. So basically, what a reference is the ability to get the address from the data type that is being stored, right? So anytime you see like an X, for instance, or any type of integer, all this is to us is basically a label for a memory address, right? Computers really only understand like ones and zeros, and then a little bit further in abstraction, they understand memory addresses, right? As humans programming, if we had to use memory addresses for our storage, that would be an absolute nightmare. We couldn't remember anything. If we wanted to store like an integer called x, for instance, and we had to remember just the address of x, like 0x1297A4, we'd have no idea what that variable meant, right? That doesn't make sense to us. That's hard to remember. And if you're making a massive application, you couldn't do it, right? So another further abstraction that programming languages give us is variable names, right? So we can actually give names to these memory addresses. With that said, C++ gives us the ability to kind of get past that abstraction and look at what the memory address is of these variables. So when we take a reference to a variable, we can actually see what its memory address is, and then we can actually access that variable through its memory address and kind of throw its memory address around between applications. So we have the address of data being stored instead of the actual data. So with that said about references, a pointer is a data type that can store a reference. It's called a pointer because most people's mental map of this is that a pointer actually points to a reference. It's going to point to an address, right? That's kind of how we picture these things, and that's why they're just deemed pointers. So we'll go over that vocabulary looking at the syntax, and then I'll go ahead and print some stuff out and try to prove this concept to you guys and make it a little bit more clear. So line 42, you're probably all familiar with this at this point, where it's just int x equals 10, right? So x has the value of 10. 43 is probably looking new to you guys for C++. There's a couple things going on here. We'll start on the right-hand side. This is basically getting the address of x. So this ampersand symbol basically gets the address of x, or gets the reference of x. And we'll see what this can print out in a second. On the left-hand side, this is a pointer type. And we know that because of the asterisk or the star. Basically, anytime you see the star paired with any type of data type, that's going to be then a pointer data type. So this is an int pointer data type. There can be a string pointer, character pointer, any type of data type pointer, basically, is what you can get. But those are just the few of the basic ones. Yeah, and then again, pointers will store the actual reference. Going into some syntactical things here, you might see it written like this, where it's int star ptr, or just the variable name equals the reference of x. Both of these are completely legal. Both of these are perfectly fine. There's a couple arguments for either one. 43, how I had it typed up. Some people picture this as it's an int, and then it's a pointer, so that they can see the variable name ptr as a pointer itself. The argument for line 44 is that the pointer variable is an int pointer data type. So they kind of put the data type all together, and then the variable name, where this one is the type of data it's pointing to, and then declaring pointer or PTR as a pointer. So both of these will work. The biggest thing is consistency, right? And I think Fox may have talked about this, or will. But if you do this in your application, make sure that's what you're doing throughout your application. If you're doing this in your application, make sure you do that throughout your application. One thing I think everyone can agree that they hate is something that looks like this. I'd recommend never doing this. No one's going to like this. This basically just puts it in the middle. It looks like they're being multiplied. You can't really tell what's going on. I'd highly recommend to stay away from this. But any of these two are perfectly fine. Some students get tripped up because they think this is like different, or they think one is illegal and the other one's legal, but they're both perfectly fine. This will work, but it's disgusting. So, okay, cool. Let's go ahead and get rid of this one, and then I'll print some stuff out to you guys to show you what's going on. So 44, we're just going to print out the variable of x just to show you guys that it's 10. That should make sense to you. 45, we're going to print out the address of x, which again is using the pointer, because pointers point to addresses. And then we're going to print out the value of the pointer because we're dereferencing it. And I'll talk about the dereference in a second once I run this. running the wrong name. And then I shouldn't do R, that should be an O. Okay, there we go. Now it's happy. Okay, so let's actually go ahead and clear this and run this again. Okay, so you can see that X just prints out 10. That's fine and dandy. And then you see this giant hex number, which is actually the address of X. So that's what we're printing out on line 45. So this is proving to you that the pointer, the data that it's storing, is the address itself. And then 46, I'm actually dereferencing this pointer. So anytime you dereference a pointer, you have to put the star in front of it, and that's what's actually going to dereference it. I think this is one of the confusing things for students, is because it seems like this star symbol is kind of doing two different things. In the beginning, it's saying that it's a pointer type, but then later on when we use it, it means that it's dereferencing. So it's a little bit confusing to look at. It's something that you'll probably just have to get used to and remember. But on initialization, the star means that it's a pointer type. And then later on, when it's already been declared or initialized, it means that it's dereferencing it. And when we talk about dereferencing, what that means is we're no longer interested in the address. We're trying to get the data that is at the address, right? So one mental model that I've heard that helped me learn these, and that I've seen help other people, and I think Fox probably talked about this too, is viewing the memory address as like an address to a house, and viewing what's stored in that memory address as the like what's inside the house. So for instance, like X is the house, and 10 is what is stored in the house or who lives in the house. And then the address of X is just like the address of that house. So data can come in and out of that memory address or in and out of that house, but that memory address will always stay the same. And we'll see a couple of examples of that in a little bit. So when we do the dereference operator here, we're no longer interested in the address of the house, but we actually want to know who lives in the house. We want to know that data that resides in that memory address. So that's a quick intro to pointers, and then we'll do a couple things with them to prove some other concepts. Cool. I got a question. Does cout pointer put the same thing as cout? Yes. So great question. So the question is, will what is on line 45 print out the same thing as this? And then the other question is, will it print out something like this? Will all three of these print out the same thing? So you can see, I'll talk about this one first because it's easy. This one's actually an error. And the big thing is because this star can only dereference a pointer. So X is not a pointer. So let's say for some reason we didn't catch this while typing it. If we run it, what you'll see is it basically says invalid type argument unary star. And that doesn't mean a lot to us, but what we should see is that like, oh, this isn't a pointer. We're not allowed to use that symbol with it, right? So this right here is just going to be like illegal. Like it doesn't really make a whole lot of sense, but that was a good question there. This one will print out the same thing as pointer. So we can run that and see that these memory addresses are the same. And actually I want to do, so I'll make that a little bit more clear. What am I? Okay. Address of X. Did this not? There we go. I'm stupid. There we go. Okay. Yeah. So these are the same memory address. And that's just because the pointer is equal to this. So these definitely should print out the same thing. So yeah. Let me know if that answered your question or not. If you still have other questions. One thing to note here too is that these memory addresses are just all right, cool. These memory addresses are just like randomly given by the OS. It actually has algorithms going on where and who it decides to give the memory to, but that's all on the OS side. So when it gives our program memory, it's just going to be seemingly random to us, right? So what we can see here is that when we ran it one time, this is the memory address of X. When we ran it a different time, it's a completely different address, right? So that's pretty interesting to see that each time we run this, if we did it again, It's just a different address because the OS is like, here's your memory. This is what you get to use. And then X is assigned to that location. Okay. Let's go ahead and do a couple more things. We can do, let's see what I was trying to prove here last time. Okay, so int, it looks like we have a y variable, and then I'm resetting x to 20. And then let's do y. Okay, let's not do this for now. Okay. So what I'm trying to show you here is basically we can use the pointer to dereference and then like use it in some kind of like multiplication, right? So if we step through here, we're making a new variable called y. That's cool. We're setting it to 8. Then 51, we're setting this new variable z equal to the value of the pointer times y, or the dereference pointer. So what I'm trying to make clear here is to actually use the data that the pointer is pointing to, we have to dereference it, right? If we did it this way, what's happening right here now, and you can see it's already pissed because this doesn't make sense. What we're trying to do on this line now is multiply the pointer itself times an integer, meaning we're trying to multiply an address by a number, which it just fundamentally won't let us do. So we can go ahead and try to run that. And you can see we're just basically trying to multiply two different data types, and that's just not a legal move. We have to actually dereference to actually get what's in the memory address or get what is in the house, right? So if we run this again, what we can see is that the value of z is 80 because the value of x was 10 and the value of y is 8. So 8 times 10, that's 80, right? So that's kind of what I'm trying to prove here. Are there any questions on that? That's basically hitting harder on the whole dereference aspect. Cool. So let's go ahead and do another example with this here. Before I actually do the multiplication, I'm actually changing the value of x, which is 20, which means that the value of this pointer is actually now going to change. So the address of the pointer is staying the same, but the value that was inside of that address has now changed to 20. So this is the concept of basically who lived in the house is now changing. 10 moved out and 20 moved in. But when I'm still trying to access this address, that address is the same. If you live in your house and I am mailing stuff to your address, and then you move out and someone else moves in, if I still think that's your address, I'm going to keep mailing stuff to there, and now someone else is going to get that mail, right? So that basically means that when we go ahead and run this, what we're going to see is it's going to be 20 times 8, which is going to give us the value of 160 instead of that original 80. So that's something that can trip people up, is they assume that when they change x, like pointer is going to follow that 10 value somewhere else, but that pointer is still staying at the same spot. And I think I've hit hard on it, but just to make that super clear, what we can do is address of x after change. What we can see here is that that address is going to be the same. So this was the address of x, and then even after we've changed it to a 20, that address remains the same. Could you do something like star point PTR equals 20, and then the value of x would change? Yes, that is a great question. So if I did this was the question, and then we go ahead and print out, let's do the value of x. Let's do, so yeah, excellent question. And we print out x here. What we're going to see is that that value of x is going to be 20. So good question, because that is something else we're able to do with pointers, is we're able to change what is in the house by referencing the address. So we're going to change what's in that memory address by referencing that address. So great question. And the answer is yes. Cool. Any questions on both of those things that we just went over? Either changing stuff by pointing or changing the value.
Yeah, sorry for the interruption.
No, you're good.
Yeah, so basically the pointer, right? When you declare the pointer, it points to memory address, right?
Right.
So when you equaling it to 20, you're basically saying that whatever's in that memory address is going to be 20 now, right?
Yes. Yep.
Thank you.
Yep. Cool. One thing, let me do this real quick. Sometimes pictures help me a lot. I end up a lot of times with if pointers get real dicey, sometimes it's helpful to like draw them. But we have this like variable pointer, right? This is just our variable, and then this is memory address like this one right here. We'll just do 34 for the end, right? Um, and 10 originally lived. Let's do a different color. Let's see here. Okay, so like 10 originally like lived in here, and this pointer is pointing to right here, right? This variable pointer is pointing to here, and then we actually change the pointer by like dereferencing it. Then that's supposed to be an asterisk. It was terrible, but then this can actually change to 20, like what's inside of here. If we did something like this, let me undo this. Sorry, this is so rudimentary. If we did something like this, where it's actually pointer is equal to the reference of y, then what we're changing here is going to be where the pointer is pointing to. So let me draw this as well. Where did my? Here we go. So this is y over here, right? So this was x. This one's y, and this is, I don't know, some other address, because let's say it's 35. What do we put in y? 8. So this is 8. So what we'll see here is if we do something like what's on line 51, then we're actually changing where pointer is pointing to, which means this arrow would get broken. It's no longer pointing here, and it's actually pointing to this location. And let me go ahead and see if I can prove that to you by doing, let's get rid of that. So pointer is now pointing to y. So if we went ahead and printed the, let's see, these aren't going to make sense anymore. Actually, we can do, we'll just do address of pointer. And what you'll see is the address of the pointer, or value of the pointer, rather. That's actually, well, I'll just do pointer. It gets a little bit confusing to say it either way. So if we go ahead and run this, what you can see is that this pointer value has like now changed. So it was pointing to x, which was this value, but now it's pointing here. And we can see this value has changed, and we can kind of look at why that is. So pointer, because it's pointing to y now, because we changed like where it was pointing, when we went down here, it's actually going to be 8 times 8, because this pointer is pointing to y, which means the dereference value of pointer is 8. So then we just get 8 times 8. So that was a switch where we did PTR equals over here, as opposed to switching what was inside of it. Hopefully that didn't confuse you guys. I may have done a poor job of making that clear. Are there any questions on the two differences there? Or I may have confused all of you. I'm not sure. Definitely ask questions on this. I know sometimes in the beginning for me, if I'm first learning stuff, I don't know what questions to ask. So that's cool. But definitely if you have them, please ask. Okay. We'll go ahead and clear all these drawings, and then we'll go ahead and look at a different example. So let's go ahead and do, don't care about that. Don't care about that. About this. Okay. So some of you might be familiar with this concept, and others might, and that's totally cool. So basically, the what we're going to, oh, I got some questions. But why use pointers as opposed to variables? My guess is change two variables simultaneously. Like if you have x, and you can change both by changing x. So that is kind of right. Where I don't know if you'll ever want to, because a pointer can only point to one thing. So sure, you could change like a X pointer and change the pointer value and the value that it's pointing to at the same time. Um, but that's not quite the helpfulness, although that is true. But yeah, Mark, we're about to see one situation while using why using pointers might be helpful. And then project two, or excuse me, project one, you guys will be building linked lists. Um, and I don't know if you guys have heard of a linked list before, but we'll go over it together. But that whole thing is going to be built using pointers. So you should come out of project one as like knowing how powerful and important pointers are. But we'll see if this example kind of helps you out and kind of visualize like why these things might be helpful. Um, cool. So what we want to do in this function that I'm making, and it's pretty simple, is basically we want to pass a variable to a function. We want that function to change the value of that variable, and we want to be able to use that variable after the function call, and not have to rely on any return value. We don't want that function to have to return to us what's been changed. We want that function to be like a void function. Doesn't return anything, but it alters the state of our variable. And then we can continue on in our program using that variable as if it had changed, right? So we'll go over, first, we'll show you how it should look like it works, but doesn't. And then I'll kind of explain why that is. So what you'll see here is we have this now it's a super simple function. I'm passing in a parameter, and then I'm going to change the value of whatever is being passed in to 20, right? So down here, it's the same thing. X is being equal to 10. We have a pointer right now, which doesn't matter too much for this. Actually, I can comment this stuff out, actually. Okay. And then what we'll see here is that we pass in X, which has the value of 10. And what we expect is after the function is called, when we do line 64, it should print out 20, right? But that is not the case. So you'll see that, actually I want X before foo. Do it this way. Try to make these prints like as clear as possible. So ignore this doesn't matter too much. But this is X before foo, so before the function call. And then this is X after the function call, which is it's still 10. So what we assumed was going to change didn't. So let me kind of explain why that is. And I don't know if Fox has gotten to this point or not yet. I'm not super sure. But I don't know if he spoke of passing by value versus passing by reference. So what we just did, when you have something that looks like this with no reference or no pointer, it is a pass by value. So in C++, the default is going to be pass by value. And when this happens, what's actually happening when we call this function and X is being passed in is it makes a copy of X, right? X lives at a certain address, and then when we pass it into a function, it gets copied into a totally different address. And then this function messes with the one that is the copied value, i.e. copy by value or pass by value. So then that value definitely changes. It gets changed to 20. But then when this function is over and terminates, like when we're done with line 62, that function is going to pop off the memory stack, which means all the memory associated with that function is going to get like deleted. It's going to get nuked, right? So that value that was copied for X is now completely destroyed. So everything we've just changed is destroyed, and we're left with our original X, which is what we're passing here. So then the question would be, okay, well, how do we remedy this? Because we want to be able to pass things in, have it manipulate, and come back to us, right? And the answer is going to be references, right? So we need to use some form of reference. And why does passing by reference fix this? So instead of passing a variable and having it being copied, we can pass the address in, and then the function knows how to actually get to that variable that we want to manipulate through its address. So we can manipulate it through its address as opposed to manipulating it by a copy of its value, which can happen. So let's kind of look at what that syntax looks like. So we can have, now it's going to be, now our parameter is taking in a reference. So this is going to be taking in an address. And that's actually pretty much all we have to change. So it's pretty much that simple. And what I'll do here is show you guys actually first, I should have left this in here. Parameter inside function, do reference doesn't make sense. And let's do the address. So showing you this, what you can see here is the address that is of X, like X's address that we're passing in, looks like this. And then the address that we actually receive is a totally different address, because again, that's the copy of X, right? That's a totally different X. We're not manipulating the same thing anymore. So if we go ahead and add this ampersand in to actually pass by reference, what we can see here, this actually still doesn't make sense. What we can see here is that we're going to get 20 now on the outside, and that's because we're actually manipulating these same exact addresses. So now that we're manipulating things by address, we can actually change what's in that memory location. And when everything is popped off the function stack and the memory is lost, that's completely fine, because the memory of X still exists within the scope of the program, and we've manipulated that. So let me know what your questions are on that, if you have any. All of this is a lot to throw at you guys at one time. Like I said, it gets kind of confusing. And it might also be one of those things that makes sense because I'm telling you, and then you go to mess around with it on your own and things start to crumble, because I know that happens to me a lot. So any questions? Okay, cool. So let me go ahead and show you one more way to pass by reference, because I think it's important to know both of the ways to pass by reference. But this is the only way you have to remember to actually like use in your program. But another way is to actually pass it as a pointer. So now this takes in a pointer instead of a reference, which means a couple things. One, we don't need the ampersand anymore because to print the address, because it is an address. And then to set this to 20, we need to go ahead and dereference it. And then down here, it no longer takes a reference to X. So we need to pass in the address because it's taking in a pointer. And then if we go ahead and run this, it's going to do the exact same thing. It's going to have the same functionality. That's just a different way of doing it. That is, if you guys are familiar with C at all, that's the only way C lets you pass by reference. And then C++ came along and was a little bit nicer and kind of changed the syntax, which makes it way easier. So that's kind of the harder syntax. You don't really need to necessarily remember that, but I think it is important to know. And it might come up like once or twice in like quizzes or anything like that. So cool. Okay, so that's pretty much all I had for you guys. I know it took a long time. Like I said, it's important stuff, and it's kind of confusing stuff. So feel free to stick around, ask any questions you guys have on any of this or anything else in the class. Like always, I'm happy to go over your like labs, like look at what you guys have going on for the labs in a breakout room. And I'm also happy to go over any quizzes you guys have taken and that you want to check, like how you did, and to review anything that you guys missed. So I don't know if you guys know, but you can't go into Canvas and look at those by yourself. You have to come into either Lab with me, or you can go to any TA or Fox and review your quiz. So you're not just limited to me to review your quiz. And then also I'm going to stop recording and sharing at this point.